Hi, welcome to video 32. This one is going to be the start of Unit 9, which is on minerals, renewable and non-renewable sources of energy. So we're going to start with kind of resources and we'll build up towards energy, probably not in this video. First kind of definition you should be aware of is what a resource is. The resource is how much material that we have that may be available sometime in the future. And so if you picture a deposit, let's talk about just an oil deposit. Deep underground, there might be some oil. And if we can reach that with our drilling technology, this would fit in as a resource, right? Because we've got access to it. But there might also be oil that's buried down deeper that we can't get to. And if that's the case, right, whether technology is not available to it or it's not money-wise smart to go after it, it would cost too much for what you'd make from pumping it. It might not be something we can get now, but it would be available for use in the future. And so we count that as a resource, even though we don't actually have access to it. It's kind of out of our reach right now. The second definition then is the reserve. And so that first oil deposit, the one on top, the one that we can get today, economically and legally, today, that's the key word, that's called a reserve. And so we could count that as one of our reserves. And so we might talk about mineral resources and mineral reserves. It's important to know the distinction between the two. The resource is everything that exists on Earth that we might be able to get some point in time. The reserve is what we have access to now, whether it's stored in a holding tank somewhere, whether it's being transported on a truck somewhere, or whether it's buried underground and we have the means and the money to go get it, and it makes sense economically. And so there's kind of some things to think about with this. There's some reserves or some resources that are discovered and also undiscovered. And so think about oil deposits out there. There are oil deposits that fall into this undiscovered area. They're called resources because they're out there, and someday we may be able to have access to them. But they're all hypothetical at this point. And so we don't know cost-wise, is it economic or is it non-economic? Are we going to be able to get to them? The ones we do know about, those fall under two categories. The ones that make sense financially to go after, that's our reserves. And we also have the ones that do not make sense, right? We can't get it. We know it's there, but we can't get to it today. And so notice this reserves box is the smallest portion of this. And so the smallest amount of the materials out there are reserves. We're hoping that there's a lot more of these undiscovered ones out there, but the chances are there also may not be, and because they're not discovered yet, we don't really know about that. So just kind of get the size of the resource. If we were to put the entire sum of the resource, let's say we're talking about the entire sum of copper resource here on Earth, every single copper atom would fit within this box. Of all the copper atoms on Earth, some of them would be up here in this upper corner as a reserve. And those reserves are the ones that are the most accessible, the most sure that they exist, right? We really know that they're there, mostly because we've found them already. And then they make the most sense to get. So that would come into the concentration. How concentrated are they? For example, gold can be found in seawater, but the concentration is so low that it's not economically viable to do. So if we're talking about gold resources here, the gold in the ocean water would fall somewhere out here in the resources box, not within the reserves. Again, same thing, we're looking at the total picture here. So the total resource is everything. We're splitting it up in the identified, the stuff we know about, and the unidentified, the stuff we don't know about. And this kind of just splits up the sizes again. So the reserve is very small. The resource is very large. So there's more stuff out there that we either know about and can't afford to go get or don't have the technology to go get, or stuff that we haven't discovered yet. And we're hoping that when we do discover it, it would be something we can financially cover. So this picture is talking about coal. You're welcome to pause the video and take a closer look at it, but I think I kind of covered it in previous slides. We've got two different classifications on these. These should be familiar to you. If it's renewable, it should be able to be recycled or renewed in the human time scale. And so we're usually talking less than 100 years for a renewable resource. This would be things like water, Air is going to be one of these renewable resources, solar, wind power, that kind of stuff. A non-renewable resource is ones that take millions of years beyond the human scale, things like coal, oil, and even some of our like metal minerals are non-renewable. And once we've kind of used them up and exhausted them, we can run out of resources we can tap, and we've got to recycle what we've already put to use. Some minerals. So minerals are really vital for building stuff, for making new things. And so where do they come from? How do we get them out? The first thing before we get into that I want to talk about is how they kind of move through the rocks that they're found in. So the rocks in the rock cycle, a rock is just a hard substance that's composed of one or more minerals, and we've got three main types of them. And so rocks are able to go from one of these types to the other. It's kind of this endless cycle that they're being pushed through over time. It's a very slow cycle, though, because we're dealing with geological time scale. But these three types of rocks are all going to hold different types of minerals. The minerals are kind of what we're really interested in here, whether we're talking iron for building or aluminum for making vehicles or any of these types of things, gold for jewelry or for wealth. They all move through the rock cycle, and we can find them in different spots based on where they are in the rock cycle. So the first one is an igneous rock. An igneous rock is something that forms from cooling magma or cooling lava. And so for an igneous rock to happen, you either get magma erupting out of the volcano and cooling on the surface, or you get magma pooling in one of these chambers and cooling and turning into a rock. And so whatever is dissolved or melted in this molten rock section of magma could be found in these igneous rocks. Sedimentary rocks are how they sound. They're formed when the sediment is deposited and kind of pressed into a rock. There's three main types here. Organic sedimentary rocks, these come from living things, and the big one here is like coal, and oil would come from living things, not necessarily a rock though. Limestone is very important for building purposes, and so it's could be either organic if it comes from shells, like coquina. If you've been to St. Augustine and seen the fort, those are coquina that they built the fort out of, and that's all limestone. Or it could also be chemical deposited limestone, which would probably be more like what you see in your house. Clastic would be just kind of like sandstone or rocks, conglomerate rocks that are bigger particles just kind of pressed together. And this is the sedimentary process here, right? The material is either blown by the wind or carried by the water into lakes or areas where it's deposited and builds up. As the layers form over time, that downward pressure and weight of the upper layers kind of pushes them into rock formation. And so the nice thing here is you can kind of judge the age of the sediments by how deep they got. You can also, in the case of coal, have a lot of sediments build up over time, especially a time when there's a lot of carbon in the atmosphere, and meaning there's a lot of plants alive, and so you get a lot of high concentration of these particles containing carbon, which is what makes coal so good at burning. Third type is metamorphic rocks. A metamorphic rock is one that's formed by heat and pressure, and so this is something that's trapped down deep under the Earth's crust, and that heat and pressure makes it undergo chemical reactions, and they can even melt to become denser, and so they're kind of squished and compacted, these other types of rocks, and they can be exposed through plate tectonics or uprisings, things that are going to bring them up to the surface, or we can mine down deep to go get them. And so when they do become a metamorphic rock, they're going to change some of their texture, minerals, and chemical compositions and form new, different rocks and potentially new minerals. So this is the economic concentration factors of some important elements. So these elements over here are all really vital things for human society. You've got aluminum for vehicles, iron for building, copper is found in electronics along with gold. Lead is important. You've got uranium for our nuclear power, zinc and nickel. So all these are things that we are going to use extensively as humans for different variety of things. We're getting all this stuff from minerals and through mining. These all have to be mined out of the ground, extracted from rocks, and we'll go over the smelting process in a later video. But all that, all these elements are essential, and this is kind of how much they make up of the Earth's crust by weight. And so you can see they don't make up a very large portion. Aluminum is the biggest of these minerals, and it's only 8% by weight. So there's not a very large amount of these in the Earth's crust, but they can be found in varying concentrations. And so this would be if we found a deposit. Let's say we found a gold deposit, because who doesn't want to find a gold deposit? We found a deposit of gold. If that were the case, then we would find 4,000 times more gold atoms in that deposit than we would in a regular area of the Earth's crust. And so the deposit's important to note, because the higher the deposit, the easier or the more viable mining that mineral might be. Something like aluminum, the deposits of aluminum are not really that rich in aluminum, and so there's not like really critical areas to go mine for aluminum. Whereas gold, it's such a high concentration factor here, they build up in one specific spot. You can have a very viable gold mine in one location, and if you went 2 miles down the road, you may find absolutely no gold at all in the soil. This is an important graph to look at because it gets at where these are going. And so the difference here, primary metals, these are ones that we have freshly mined and are just fresh out of the ground to be used. And you can see that over time, going back to the 1960s here, this line has stayed more or less flat, and maybe a slight downturn to it. The encouraging thing are the recycled side here. So our recycled amount of metals are increasing, and we got a pretty steady upward trend. And so what this graph is showing is that while our demand for metals is increasing, we're not really taking out any more from the ground than we were previously. Instead, we're recycling ones we've already extracted, which as environmental scientists, this makes us very happy, because the mining process can have a host of problems associated with it, and this recycling is generally cheaper, it's generally easier on the environment, and that's going to be it for video 32. So please take notes and bring ideas to discuss with us in class tomorrow. Thank you for watching.